Let me explain using Xilinx application software how to develop Verilog programs. Xilinx software can also be used for developing VHDL programs, but let's understand how to use Xilinx for Verilog. I double click Xilinx. I'll make it OK. So let me go to the file. I close the project which are on the screen. I start my own project, new project. Let me choose some drive to start my project, a new project. I give name something like PSC 777. Project is a group of files. Each file can have different modules. So each module is a file. Let me do next. The first half of this section has details or specifications of the device which we are using in the kit. The FPGA kit is having a trade name as Spot on 6, which is to be selected. Like that, other details have to be noted and properly selected. The second part indicates the software details. We have two ways of testing the program. One is synthesis, that is implementation of the circuit into the device, into the memory, or downloading. Simulator means checking of waveforms used by iSIM software. So you have to check these two tools being selected here. So next, finish. Now I enter the project, a new source, Verilog module. Let the new source be called as R1 to demonstrate OR gate. Next, here module declaration part has come. A comma B, I'll make it as input. Z as the output. I change the direction here of the port as output. I am not clicking bus here. Bus for signals of multiple inputs, multiple bits. Here I am using each signal as single bit. So I am not clicking on bus here. Next, finish. Now there are three sections, as you can see, four sections in fact. One section is for source, another section for process, this section is for program, and this section shows errors if there are any. So let me enter the program part. Already module declaration has come. I'll go to the second part, that is functional part. I make the output as register because that is a necessity in behavioral modeling. I am using behavioral modeling to describe OR gate here. So expressions will come within always. I have to use only the small case letters for keywords. As you can find, keywords are in blue color. And it is a case sensitive. Capital and small are different. So I have to be careful. I begin the always. So always is the part of the section which is going to have the functional part Boolean expression. Z is equal to A, perpendicular line indicates OR operation, A or B, semicolon. I end the always because only one expression is required to describe the gate. So end module has come. This end is for always, the other end is for module. So I am not doing implementation here. Implementation means downloading into the kit. I am not doing. I go to simulation. I double click on the file name, iSIM simulator plus open. I double click simulation, simulate. Waveforms shall open up. Now I go to input part, right click, force constant to 1 I apply as one of the input. For the second input, I apply 0. So 1 and 0 I am applying for inputs, and I run the program to find 1 as the output, because OR gate, if two inputs are 1 and 0, output is 1. I want to change the input in the sense I have to go to relaunch. So it resets. I go to input again. This time I apply 0 as one of the input. I force constant the second one as also 0. So I apply OK or enter. Both the inputs are 0. I run the program. Output is also 0. So sharp line indicates 0. Shadow line indicates 1 in the waveforms. Now I close this simulation application. I go to program. I change the file name as and this time OR operator is changed to ampersand. Ampersand represents AND operation. I save this, so that file name changes here. I double click that. I go to simulate to run the program on simulation application. Now this time I apply one of the input as 1, another input also as 1, then output should be 1 actually. I run the program to find all the three signals are shaded, means all the three are 1. Two inputs 1 and one output is also 1. I close the simulation. I return to the program. This time I change the name of the file as XOR, and only one change in the functional body, that is rider is coming, which is the operator for exclusive OR gate. I save that program. I double click on the file, simulate. This time XOR truth table can be verified. I make A, I force constant A as 1, I force constant B as 0. So two different inputs will yield 1 as the output. 1 and 0 will yield 1 as the output. If both were 1, 0, both were 0 means 0 will be the output. So only when different inputs are there, XOR output leads 1 as the output. So 1 and 0 has yielded 1 as the output in XOR operation. I close this XOR gate simulation. I now take up NOT operation or inverse gate. NOT